Any printout is composed of dots, and there are essentially two basic approaches: binary imaging and multi-level halftoning, such as HP's ImageRET. Let's take a look at these two imaging technologies and how they impact the user's experience. In binary printing, there is a single size of dot in a fixed position in each cell. The dot is either on or off. If it is on, it can only be one of the four primary colors: cyan, magenta, yellow, or black, or simple combinations of these: cyan and magenta, magenta and yellow, cyan and yellow. The impression of a color is created by placing tiny dots of the 7 different colors in various combinations next to each other. That is, cyan beside magenta, magenta beside yellow, and so on. The design of binary imaging printers is relatively simple, and the only way to increase the resolution is to use more, smaller dots. That is, instead of 600 dpi, you use 1200 dpi, and so on. However, just placing more and smaller dots increases memory requirements and network traffic, without being able to completely eliminate print quality issues due to print algorithms. Multi-level halftoning, such as HP's ImageRET, is a far more complex approach that uses dots of various sizes at various positions, combined within each cell. This takes more effort in development, but apart from more accurate colors, it has some key performance and real resolution benefits. On binary printers, there are significant performance penalties when printing in the highest quality mode. Performance can be half or worse of the speed of default mode. That is because the printer processing system is tuned for the default mode, and when you switch to best quality, the processing system has to struggle to handle the quadrupled data. HP's ImageRET has only one print mode, and the processing system is always able to cope. Apart from achieving a greater variety of smooth color shades, ImageRET also copes with difficult cases, such as producing sharp edges for text and graphics. For example, when it comes to making text look crisp and clear, a collection of single-sized binary dots makes an uneven approximation to the ideal edge. The intelligence in HP printers detects such eventualities and positions various sizes of dot to better match the ideal profile. The result is a clean edge. There may also be mechanical discrepancies between color planes. Specialized publishing software, for example, usually has software mechanisms to compensate for this and prevent white edges from showing up around text printed on colored backgrounds. This is called trapping. HP printers don't rely on software for this correction. Microsoft Office, for example, does not do this. HP printers detect potential alignment trapping problems and correct them in the printer by printing a little more of the background color under the edges of the darker text. For areas of solid color, lower resolutions generate more stable, smoother fills. With a binary printer, if you switch to 1200 dpi for greater detail, you lose this stability, resulting in streaking and banding. ImageRET systems, on the other hand, continues to behave like a 600 dpi printer to ensure smooth and solid fills without compromising on the level of detail. To support this, HP's chemically grown toner has a consistent shape and size that means it can be precisely placed and fused on the page. Printers with multi-level halftoning guarantee the user great output right out of the box, with less waiting, less trial and error, and less reprinting. Multi-level halftoning is clearly a preferable imaging technology to binary printing, and nobody has more advanced halftoning technology than HP color laser jets with ImageRET.